Okay, we're going to start looking at motion, and we're going to go with the first section here, describing Walker motion. To describe motion, first thing we need to have is a frame of reference. So a frame of reference is where you are looking at the object. In physics, we use a coordinate system just like you would in graphing with an x and y, with positives going up and to the right and negatives going down and to the left. The origin, of course, is going to be 0. And then once we choose a positive direction, we will keep positive right and up for ease of use. We use x to label position, okay, but it doesn't necessarily mean we're always going to be horizontal. It could be also in the y, which would be vertical. And then we just talk about drawing from the origin. That would be our x, okay. Whenever an object is moving, it has changing position. So let's take a look here at some terminology here. Initial and final positions. Initial position is where we start, right? Here. And we use x sub I. Final position is where we finish, x sub f. The arrow shows the direction that we're going, and of course we do have an origin, which will be where 0 is. So you've got to have an origin, initial position, and final position when we talk about motion. Distance is the total length taken, okay? There's no direction, which means it's a scalar. So distance is a scalar. Meters are how we measure distance. When we walk, we use a pedometer, step counter. In a car, we use an odometer. Those are just different ways to measure distance. But again, distance is a scalar. So let's get an example here. So here's our figure 2.2. What is the distance from the grocery store, okay, here, to your friend's house, which is here? So we're going to walk in this direction, okay? Our origin will be here. We'll call this 0, and we'll travel this way. So to our house, it's 4.3. From our house to our friend's house is 2.1. So we're just going to take 4.3 plus 2.1. 6.4 meters is the distance. Always choose an origin. Displacement is defined as an object's change in position. Displacement is a vector having both magnitude and direction. The SI unit of displacement is the meter. So the meter here, right, displacement is a vector because it has magnitude and direction. Now, the sign of the displacement vector shows direction, okay? So like we said earlier, anything going to the right and up is positive, anything going to the left and down is negative, okay? But negative and positive don't mean anything other than direction, unlike in math class. So we use change in x to show displacement. Change in x, delta x, is the same as final position minus initial position. X is positive when we're going to the right, and it's negative when we go to the left. So for example, you look down here, we're going from 2 to 6, initial position, final position, therefore 6 minus 2 is 4, and we're going in the positive direction. If we go back and we start at 6 and go to 2, we go 2 minus 6, which in this case is negative 4. So again, negative just means we're going left, and positive means we're going right. Now, difference between displacement and distance. Distance is total length traveled. Displacement is the net change in position, and we'll look at an example of that. If you run in a circle, so you start here and you finish here, your displacement will be 0 meters, okay? Even though you may have traveled a considerable distance in track, you would have traveled 400 meters. But because you finished where you started, your displacement's 0. So here's an example. The total length traveled in going from the math classroom here to the physics classroom here, okay? Oh, then the library, then the physics classroom. So we're going to go from the math classroom to the library, then to the physics classroom, okay? So think about where we travel. We start here. We travel 3. Then we go to here, which is 5. And then we travel back, which is 5 more. So we have traveled a total of 13 meters in distance. But our displacement is this way, so it's 3 meters, but since we're going left, it's negative 3 meters. So distance is the full path traveled. Displacement is where we start to where we finish. In this case, negative 3 meters. So, what is the displacement for a trip from the physics classroom to the music classroom and then to the math classroom? So you're walking your buddy to class, right? We want to know displacement. So we start here and we finish here. So we're going from 5 to 8. All right. So we take final minus initial, and that gives us 3 meters. So our displacement's 3 meters, and since we're going right, it's positive 3. What's the distance on the trip? So let's think about our distance. We started here, we walked to here, and we walked back. So we went this way, 3 meters. 8 to 14 is 6 meters. Then 14 back to 8 is 6. So I go 6 plus 3 gives me a nice tidy 15 meters. Now, we don't put a plus or minus on this because we talk about distance. Distance is a scalar. Alright? Scalars have no direction, so therefore we don't have a sign of positive or negative. It's just 15 meters that we traveled, or distance traveled.